Hi there. This is a video where we're talking about double free vulnerabilities. So another aptly named bug class, thank you for whoever named this, it's where we free the same pointer twice. And now we have a similar issue where two chunks are now waiting to be reallocated from a particular bin. And there's other ways to exploit this, and we'll talk about that in a minute, but I think this is the easiest way to think about it. If the bin is just a list of pointers, then if we free the same chunk 5 times, it's going to try to allocate that same chunk a bunch of different times. So by doing that, it's possible to get the same pointer in a bin to point to something multiple times and therefore get it allocated multiple times, which is really cool. Now, I want to do the hotel analogy again. I think it doesn't work as well for this, but I think it's worth doing still. So close your eyes. Imagine the memory is the hotel, the memory allocator is the hotel management, and an individual piece of memory is the hotel room. You have a great time at your conference after you've picked up your room key, but you're feeling particularly devilish today. When you go to check out, you check out once, but then you check out again. And by doing that, by checking out more than once and actually giving your key back that second time, the room can now be assigned to 2 different people. The hotel management thinks that this room has been freed or given to them on multiple occasions. So you end up having 2 people booked in the same room at the same time, which is bad. And maybe you're the second person that got that room, so you're able to access this person's stuff when you shouldn't be able to. All right, open your eyes. I know this one doesn't work as well for it, but I still think it's worth talking about. And the key difference here is that instead of keeping your room key, you're just checking out twice. And this allows for a linked list to have the pointer in it twice, and therefore the management goes, okay, what's the next room we can give out? Oh, this room. When they do that twice, you assign the same room to 2 different people. And that creates all sorts of havoc. Anytime you have ownership of the same memory multiple times and each pointer has a different understanding about it, you would have major problems. So to explain the most primal double free exploitation, we're going to allocate a pointer with malloc. After doing that, we're going to free the same pointer twice. When we free the same pointer twice, it's going to have a bin that has 2 pointers of the same chunk in it. That's where you see here. We have a bin, and then we have chunk 1 and chunk 1 right after one another. Now, if we allocate 2 chunks, both pointers can edit and view the same section of memory. This is bad. This is the use after free all over again, just with an extra step. We'll go over the challenge in a minute, but I want to talk about some difficulties with double frees first. So modern glibc actually has pretty good protection against double free bugs. The T-cache is the only bin that doesn't have any sort of double free protections. That was only in 2.26 to 2.28. In newer versions, it actually has a parameter called key, and if that key value is set to a magic value, then it crashes because it knows it's been freed multiple times. However, there are ways to bypass this. I'm going to turn off my camera to show this the best way. The fast bin will only check for the next chunk. So for instance, if I free chunk A and then chunk B and then chunk A, because chunk A is not chunk B, it doesn't work. It can't actually tell that this was freed or chunk A has been freed more than once. However, with the fast bin, if you free chunk A and then chunk A again, it will crash. So this is called fast bin duping, and it's a fairly common exploitation technique. There's also other mechanisms. There's the House of Botcake, which works by filling the T-cache with 7 chunks larger than the fast bin, putting one into the unsorted bin, the same size, allocating one of the chunks of the T-cache, and then when you free the unsorted big chunk again, the 2 chunks consolidate together. Now you have one reference within the T-cache, and another one from the backfilling process in the T cache as well that doesn't check. So there are ways to get around these double free protections by abusing the allocator, but it's not the easiest thing to do. But there is one form of double free that is much, much more common, but it's a little bit more complicated. And I call this a staggered double free. The idea behind this is exactly what's in this meme. It's not a double free if there's only one chunk in the allocator. Now, what does that actually mean in this context? Well, if I free something and then it gets allocated, and then I use that original pointer to free it again, we can free something multiple times without actually triggering the double free protection. Because the double free protections we talked about require a chunk being in a bin more than once. So we'll go through this step by step. First, we have pointer 1. This points to chunk 1, but pointer 2 needs an allocation, so we're going to free pointer 1. When we free pointer 1, it points to this bin. Now, if I were to do a pointer 1 free again in modern versions of libc, this immediately crashes because of the double free check. So I'm going to allocate this to pointer 2. After I allocate it to pointer 2, pointer 1 still has a reference to it, and it's no longer in the bin. It's no longer in the allocator. So the allocator actually can't tell the difference between which pointer is going to free it. So we can use pointer 1 to free chunk 1. And now, pointer 2 actually has a use after free on it now, which is pretty awesome. We never actually had to use pointer 1 to write to it, but now pointer 2 has a use after free. This is the more common version of the double free that gets exploited. The glibc malloc exploitation techniques are fun, but this is much more likely to happen in practice, and it creates very good primitives. Because if I have a pointer to something and it gets reallocated later, that means that I can arbitrarily free any pointer that gets referenced to this, and this just makes a much better and better primitive as a result. So to recap on the staggered double free, we're going to free it, we're going to allocate it, we're going to free the same chunk again, and then when that gets reallocated, it causes use after free. And no library is ever going to catch this double free technique. It's a pretty standard technique, and it'll work in most allocators. If you want to play around with double frees more, besides the exercise, there is also what is called the double free playground. It has an assortment of double free bypass situations where you can mess around with it. Different versions of libc have different situations and different exploit techniques you can use. Of course, I'm going to go through the double free exercise for you guys as well. So I'll see you guys in that video.